All right, guys, welcome back. We're at the end of activity 30. We're doing activity 30.3. We're kind of going over the questions there, and I'll give you a homework assignment for the activity. Coach Williams again. So, question number 4, I assigned basically questions number 4 through 12 just as an FYI. So, if you haven't worked them yet, go do that and then come back and look at these. Question number 4, the magic here is Pythagorean triple. We talked about it over and over and over. They just keep coming back. This is an isosceles trapezoid, meaning that if I drew another height here, this length would have to match this length here. This height would still be 4, so 5 squared minus 4 squared, I get this length is 3. This length is 3, bring down my 2. It allows me to solve for that base. That base, all total, is going to be 8. So if I have 1/2 of 2 plus 8 times 4, because that's my height, so 1/2 of 10 is 5 times 4 is 20. So number 4, the answer is 20. For number 4b, notice that we have a 45-degree angle here. That means that this is an isosceles right triangle when I draw my height. So if this length is 4, this length has to be 5. So my formula is going to be 1/2 4 plus 9 times 5. Well, 4 plus 9 is 13 times 5, and then take half of that. Your answer is going to be 32.5. Hopefully you're good with that. Number 5, density. All you're going to do with density for us for this course is you're simply going to multiply whatever the square footage is, you're going to multiply that times the density, okay? And so we've got 2 types of wood here. We have red cedar, and then we have maple. And the question is asking us, hey, what's the cost difference in shipping these? They're telling us it's 50 cents a pound to ship. So you need to find out how much each one weighs, then multiply by the 50 cents to get the cost, and then compare the 2 costs, and so that's what we did. It's 23 pounds per square foot for red cedar, and there's 4 feet, so it's 92 pounds times 50 cents, it's $46. For maple, it's 45 pounds per square foot, 4 square feet, so it's 180 pounds total, and it's 50 cents a pound, so it's $90. 90 minus 46, we get that our maple is $44 more. Okay, good there. Number 6, pretty straightforward. Your first one for 6A, you're going to get 64. And then for B, you're going to get 133 square root of 3. That one is, again, not Pythagorean theorem, but special right triangle. So you get 133 square root of 3, or maybe you got 230.4. Either one of those answers would work. For number 7, it's another density problem, and you're just multiplying 20 times 30, so you get 600. For number 8 is kind of an interesting problem. They're talking about a rhombus with isosceles trapezoid with base lengths of 2 and 5 and a leg length of 2.5. I just want to kind of show that one real quick. So basically what you have, this length is 2.5, this length is 2.5, so it is isosceles trapezoid. This is 2 and this is 7. When we draw our dotted lines here, this is 2, this has to be 2.5, this has to be 2.5. Sorry, not 2.5. 4 on top, yeah? 2 and 5, 2 and 5, that's what's wrong, sorry. This is actually a 5 down here. And so we get 1.5 here. I knew there was something off with the numbers there for a minute. So base lengths of 2 and 5. So we get 1.5, we get 2.5. This is a 3, 4, 5 triangle as well, even though it's kind of half of that, right? What's half of 3? 1.5. What's half of 5? 2.5. What's half of 4? 2. So my height is 2. So my formula here would be 1/2 2 plus 5 times 2. Well, the half and the 2 cancel, so 2 plus 5 is just 7. Hopefully that makes sense. But I thought that one's kind of interesting. We just want to take a second to show it. Number 9, rhombus with diagonals of 6 and 10. 1/2 times 6 times 10, you get 30. Number 10 is 192 square root of 3. That's the 30, 60, 90 triangles in those corners. So half of the isosceles length, so half of the 16 is 8. So the height there is going to be 8 root 3. When you plug in the 8 root 3 for the height, you're going to get 192 root 3 for your answer for number 10. Number 11, I like, probably my favorite one here. I did a drawing just to show you. I don't know what the bases are at all, so I did x1 and x2. They tell me that perimeter is 32 and area is 54, and they want me to find the height. So let's start with the perimeter. Why am I going to start with the perimeter? Because what's it do? It allows me to solve for x1 plus x2. I don't know what each one is individually, but I know what their sum has to be. Why? Because if the perimeter is 32, Well, that means this plus this plus this plus this is 32. So technically x1 plus 7 plus x2 plus 7 equals 32. That means x1 plus x2 equals 18. Okay? And notice this right here comes out of the formula. The formula for area is 1/2 b1 plus b2 times h. Well, my two bases added together have to be 18. So I can just plug in the 18 there. 1/2 times 18 times h equals 9h, because a half of 18 is 9. So 9h equals 54. That's where this equation comes from, and then we just divide by 9. We get our height to 6. Again, probably my favorite question in this section. Number 12 is pretty straightforward. It's just some big numbers. So you're going to do composite figures. You've got a trapezoid, you've got a parallelogram, you've got a rectangle. Trapezoid, I got 472 for the area there. The parallelogram I got 288. And then the rectangle, I got 952. All that added together gets you 1712. And then you're going to multiply by what they say the stuff weighs. They say it's 856 856 pounds per square foot. And so when you multiply that out, you get 32,528 pounds. Okay, that is the end of 30.3. Your assignment, your homework is to go to the next page, page 445 through 6. Questions numbers 2, 4, 7 through 9, and 12 through 16. Remember, you can do all the questions if you want, but numbers 2, numbers 4, numbers 7 through 9, and 12 through 16 are the ones that we would feel would be the most beneficial to you on the upcoming test. Good luck, guys.